Hello, we are the team L&R Consultants and Networking Solving. Thanks you for first. We are going to say the major problem that you present to us. The university needed a network capable of supporting thousands of users. Each building required networks per floor with independent segments for each kind of host. In addition, all buildings needed to be communicate with each other without delays, IP conflicts, or packet loss. Well, for this, we solved the problem by designing a structured network based on professional cabling system, switches, routers, and principles of the OSI model, OSI. We began by organizing the physical layer by the placement of switches and access point on each floor of every building. This ensures a startup and stable physical foundation of the entire network. Next, we apply the data link and network layers. Mm, these control the devices communicate locally and between buildings. While routers manage the IP-based communication between buildings, we use BLSM, but we calculated and assigned subnets for every group of users, guaranteeing that each device receive an IP of its network. Finally, we implement DHCP servers to automate address assignment. Well, for this, we just put two switches for each network, but they are capable of having the users that the requirements of the project has.
The router strategy, the logic. Given the requirements is use a static routine, I designed a strategy to do this. Outbound flow towards internet at the campus. I implement a default route on all ditch and flow routers. The logic is if the destination is unknown, forward the packet to the next upstream routers to towards the center. This drastically reduces the size of the routing tables on the smaller routers. Inbound flow. On the building's core routers at the campus routers, I configure specific static routes. These intelligent routers know exactly which interface to use to send traffic down to reach a specific network. Chain management. For flows with routers connected routes to prevent routing loops.
Okay, so I'm going to tell some of the advantages of the final project that we have. Lastly, the entire design networks follows industry standards, ensuring that the project is both professional and capable of supporting the university's long-term technological work. Um, Other is the DHCP automatization and BLSM planning that prevent IP conflicts and guarantee smooth operation.
Disadvantage. The first disadvantage is single point on failure. The entire inter-building network relies on the campus routers. If the central campus router fails or loses power, all three buildings lose communication. 2. Increased latency due to daisy chain topology. Because the routers on each floor are connected in a chain, data from the farthest department has to jump through multiple routers to reach the exit, which slightly increase network latency. 3. Low fault tolerance in floor segments. If a router in the middle lost the communication, all the routers lost the communication to the, to, to the to the floor. 4. High administrative overhead static routing. We use static routing in case of dynamic protocols. This means any future change of network expansion requires manual configuration on multiple routers. And 5. A bandwidth bottleneck of the building core.
Another advantage is that we just use the necessary equipments. So this is the cheapest way we found to solve the problematic that you just present us. And thanks for hearing us, and we hope you select our presentation. Thanks.